Good morning, good afternoon, good evening, everyone, wherever you are in the world. My name is Ron Dagdag, and today I will be talking about mixed reality for JavaScript developers. Um, and let's get started. A little bit of background about me. I'm an R&D manager at 7-Eleven, and also I'm a Microsoft MVP. I've been awarded categories in mixed reality, in the Internet of Things, AI, and Windows, and also been a Microsoft MVP for you know, 7 years now. All right, and of course, in between my presentation today, I will be talking about a little bit called Rubik's Cube, yeah. It was originally called Magic Cube, but I'll integrate this with my presentation. All right. So today our agenda, only a few things. We're going to talk about what is mixed reality, a little bit of background there. Um, what is it? What is mixed reality in the web context? And also, what are the open source JavaScript libraries available out there that we can start using to start developing on this platform? Let's get started. So what is mixed reality? Most likely you already know this because you've been attending a lot of the sessions today, but I wanted to make sure that it is a blend of physical and digital world that unlocks the natural and intuitive 3D. There's the human, right? And then there's the computer. Usually, whenever humans interact with computers, we call that HCI or human computer interaction. And then now we are integrating the environment around the human and the computer. And that's where mixed reality comes in, where there is the human side, the computer side, and then knowing the environment and how it would interact with each other. So mixed reality is possible because of the advancement, not just in computer vision, but also in the graphical processing side. A lot of the new display technologies that have come up for the past few years have gotten better, have gotten slimmer, easy to be portable. There's different input systems, not just sound, not just speech, but also hand detection, a lot of the computer vision that's coming out there, uh, and the AI helping have better input systems. And of course, cloud computing. Because of all these technologies, now we have devices that have a way to understand its environment. Uh, we typically call that spatial mapping and anchors, uh, being able uh, to figure out where you are located at and what's around you. The human understanding side, like I said, there's the hand tracking, not just that, but there's eye tracking on these devices, there's speech input, and all the different things that we can track movements, not with all the different sensors that we have. And then, of course, spatial sound. If you're an avid gamer, a lot of the games and a lot of the the games that you're using right now have these capability of these spatial sound to identify how far is the sound coming from. So whenever you wear a lot of these VR glasses, it has a capability of identifying where that sound is coming from. And then the location and positioning, not just the virtual space, but also physical space. It has that capability now. And then, of course, with all the different tools that's happening that is out there, making it easy to create and collaborate to create 3D assets in mixed reality spaces. So a lot of these new technologies have come up. That's why we have mixed reality. Um, and I like this representation. What is mixed reality, right? There's reality, which is the world we live in, and then there's virtuality, all the video games out there that's all virtual worlds, typically called virtuality. And then there's the mixed in between those, where you have augmented reality, where you're adding virtual objects into the real world, or the augmented virtuality, where you're importing parts of reality into the augmented world or the virtual world. And all that is a mixture of what is mixed reality is. So there's different types. Most likely you've experienced them because it is something that we use every day and it's already out there. On the virtual reality side, there's the non-immersive VR, which is typically an example of video games. A semi-immersive VR, a good example of that is the 360 virtual tour. You know, there's in YouTube, there's a way you can have a 360 virtual tour where you can have a visual connection to the real world. And then there's the fully immersive VR, where you wear the VR glasses and it can completely immerse you into a virtual world that blocks out what is the real world around you. And then, of course, the metaverse, which is the social VR side and the collaborative side, where multiple users can be in one place that can interact with each other in a virtual environment. All these uh, are part of the of that um, of the mixed reality. And then on the augmented reality side, there's the marker-based AR, where it uses the marker or sometimes QR code or image to trigger the display of a virtual content. Um, and then there's the markerless side, where you don't really need a marker. It just knows on the real world environment, you can put virtual content without um, and then it identifies which one's the surface it can place content on. And then there's the location-based AR, where it's specifically, you know, that you have to be in a certain place in order to show the virtual content. And that's when you talk about those Pokemon Go games where you can be in a certain location to access that the avatar. And then there's the projection-based AR, where you're using the projector to display virtual content in the real-world surfaces. There are places where you can play these games where you don't have to wear a helmet. It's all projector-based, and it tracks the people around or the people playing. And then there's the superimposition-based AR, where you can replace any virtual objects in real world. So I see this as like when you're in a factory, you can be wearing these HoloLens and being able to get the the status of a certain machinery, or maybe you are in a factory or you're in a construction site, and being able to superimpose some parts of the virtual building into the real world to overlay and what it would look like after it was built and those kind of things. So the whole idea is providing the real time information of what the current status of that uh, of those sensors that is around that virtual that space. Okay, going back to the Rubik's Cube, there are about 43 quintillion possible combinations on a Rubik's Cube. Isn't that interesting how you can, how this piece of device can, it's, there's ways, how you solve it, but possible things that you can go wrong. What is WebXR? WebXR is a unified API for these VR and AR devices. And the cool thing is it already has been integrated into a lot of these headset. These VR headsets have their own browsers, and these browsers can have VR websites or WebXR websites that allows it to use the sensors in the browser. So there's AR glasses, even smartphones with browsers that has the WebXR. It's a web platform and ecosystem. In order to get started on this one, I recommend going to this immersiveweb.dev, and it is open source, this immersive web GitHub, and it is a platform. And just want to let you know that the iOS support is still experimental because the Vision OS is still on the works. And I believe it's going to be part of the new platform that's coming up with Vision OS having a WebXR component. So what is the advantage of WebXR? One of the good things about WebXR is what we call permissionless publishing, meaning it's an open platform. If you're a web developer, a JavaScript developer, the one thing that attracted us to doing web development is because it's, if I have a code, I can just publish it, send it to, and then it's out there. I don't need to go through different gates in order to be able to publish my web app. Another is this send, it's shareable. One of the advantage of WebXR is because you can, once you have the URL, you can share that, send that link, and another person can start experiencing or start that experience. So it's easy to be able to share the application. Another is it is very accessible. It has a low barrier entry, just like any. The reason why we have lots of web developers out there and JavaScript developers out there because of these. And for WebXR to be able to, for mixed reality to be able to be out there, we got to have low barrier entry, and that's one of the reasons why we, that good advantage of WebXR. And then the cross-platform side, the idea of just works, of course, because it's still an ongoing platform and still has some releases. There's some, depending on the browser you're using, it may or may not work. But the whole idea is I can be able to deploy it on, a mobile app, or, maybe on the HoloLens app. It has a browser, it has a Edge browser. Vision OS will have its own browser, and it will work. It will just work on there too. And then of course Meta, has their own browsers to be able to view these WebXR content. And then of course, I don't know if you've heard about OpenXR. What is the difference between WebXR and OpenXR? Pretty much they're about the same. They're actually an abstraction of the display and the input sensors that is already on these devices. So they are an abstraction to make it easier for us to be able to do development on top of those libraries. The difference is that WebXR is specifically made for websites. OpenXR is for installed applications, meaning if you, let's say in Unity, they have OpenXR, you can actually create an application that would run on the, on the Meta, or you can have it to run it on other VR or the HoloLens or other VR or XR or devices out there. WebXR specifically made for websites. So, and that tells you that there are OS independent. So once you build a WebXR application, it's the same app. It does not change. In OpenXR, you have to compile it specifically for the OS you are deploying it to. So that's the main difference between the WebXR and the OpenXR. Feel free to put in the chat if you have any questions. I can't see it right now. I will answer some of these questions later on, but feel free if you need some clarification in some of these items. Okay, going back to the Rubik's Cube, it got broken. The world record got broken this year by this guy, is Max Park. He broke the record 3x3 Rubik's Cube, and he finished it in 3.13 seconds. I think it is amazing work, and you can see how he solved it in just 3 seconds. Over just a little bit over 3 seconds. Okay, let's go to the different JavaScript libraries that is available out there. to get us started. Today I'll talk a little bit about model viewer, and then I'll show a little bit of demo how that works, A-frame, and then there's also Mind AR, and then Babylon JS. If you've been a JavaScript developer for a while, there's always where you can use 3JS and has a way you can connect it to WebXR. On the right side, there's MediaPipe, React XR, Wonderland Engine, Play Canvas, and Snap Studio. I don't have time to talk a lot of each one of these. MediaPipe, I'll discuss a little bit about that, and then Play Canvas, but we'll focus on these few items for now. Okay. All right, so we'll start with the model viewer. So if you go to modelviewer.dev, it's interesting. I want to show you guys what that looks like. So if you go to modelviewer.dev and notice how it has this 3D model, and it takes just a few line of scripts in order to integrate this model into your web app. And it's easy to get started on it. There is also a model viewer. Let's see if I can get to the editor. So the editor itself, you can just drag in a GLTF file. See if I can do that here. So I have this Rubik's Cube. And what I'm going to do is I'm just going to drag this. And now I have a snippet and what I can incorporate into my application. And then you can even download it, create a poster, and all that. So for my demo, let me see if I can share my screen right here. Okay. See if I can get that connected. You see my screen. This is my phone. I have my, okay. So on the model viewer right here. So that is the app. I can have the 3D model, and then I can click this view your space, and notice how you can drag in and out. You can zoom in and out a 3D model just like that in few lines of code. Not cool? So that is model viewer. Let's see if I can go back to the presentation. So notice how it's a custom HTML element for displaying and viewing 3D in AR, and it's just a few lines of code, and it's HTML code in order to get this. Cool. So that's a good example of what you can do. Okay, let us go back to the Rubik's Cube stuff. This one is the most expensive Rubik's Cube out there. It costs about $2.5 million. It actually got created back in 1995 to commemorate 15 years anniversary. 30 years anniversary is gonna come up soon too, so I don't know what's gonna be next after this, but that's amazing. Okay, let's go to our next one. Next one is A-frame. A-frame.io is a web framework for building 3D and AR experiences using a combination of not just HTML and JavaScript. Here's an example. This is my HTML page. You have your, you add your script, and then here, notice how you're specifying a scene. A scene is, think about it, you're a director and you want to be able to locate where these items or where the actor is going to be. In this case, there's the box, sphere, and cylinder, and you're placing it and you're positioning it into certain locations. And notice how it's specifying the position. Usually that is the position in in virtual space, and the rotation, those are degrees or radians also. And then, oh, actually those are degrees. And then you have color, which is those CSS colors that you would use for your web pages. And then you have to specify the color of the sky, what is the background image or background color, and locate the, the position of the plane. And then that's it. You have your first A-frame script or A-frame page, and this is what it's gonna look like. And notice how you can browse through it. You can press WASD to move around that virtual space, and it allows you to have some debugging too. So let me see if I can get to that. And do aframe.io. There's a lot of examples here, but this is the one we are working on. And then you have the model viewer. If you just want to pop in a 3D model into that space, you can have it to where it will open a model like this. You can zoom in, zoom out, and you can view it in VR. So let me see if I can show you an example on what it is on my phone. So this is an A-frame. So here's an example of like a 3D or a 360, because you can use it for 360, not just videos, but also images. But I did add the Rubik's Cube in there, but notice how there's lighting. It kind of detects what the lighting is. It's darker on the left side, so it has the shadow and lighting estimation. I can click on VR. So if I am, let's say in my, in my HoloLens, I can use this, or if I am on my Meta glasses, you can use it to be able to view it in VR. But on the AR side, I have the app here. See, notice how it can kind of locate where it's going to be, just places it there. It's not always perfect. Notice how it does not kind of stay where it's at, but it's something we can start using right now if you just want that certain models in your 3D space. Okay, but there's some examples here. There's a way you can see videos, you can get you started. And there's also where if you want to use the controllers, you can do that in VR too. And has that a way to be able to get the controller values or the controller data into so that's what WebXR allows us to do, not just the visual side, but also the controller side or a lot of other sensors that it's coming. Okay, let's go back to the presentation. Okay, going back to Rubik's Cube. Someone actually solved this Rubik's Cube while skydiving. It took him about 30 seconds from the top, jumping out of the plane until it falls in the ground. I don't know if I'm going to do that, but that's not one of the things I would want to do. But it's interesting though. Mind AR, another open source util out there. Actually, Mind AR uses A-frame in order to have the virtual or be able to visualize it. It's a web augmented reality library that supports image tracking and then face tracking. It is on GitHub, and that is the link on GitHub. There are a few caveats. There's good tutorials on how you would use this. So here's a good example. Notice how it's using the A-frame library on this one, but it also the A-frame, the MindAR JavaScript library. And this one, we create a scene. We're looking for this MindAR image that has the Rubik's Cube, and then it looks at and then we load the model. This is the Rubik's Cube.glb model. GLB is the binary representation of GLTF, which is a 3D model. And then this one is, once you see it, the target, the image target, it locates where it's going to be displayed. And that's about it in a few lines of code. Let me see if I can do this demo for you. Okay. So to do this, there is MindAR. Notice how it's just spinning and it's scanning for something. And what I'm going to do is I have these image poster, and once it finds that poster, notice how it places the 3D model or that Rubik's Cube on top of the image. And that's what it's doing right now. And that's what we can use it for. Okay. So say that's what it does. Once you scan, it finds a certain poster, then it will display something on top of it. You can use it to play videos, or you can use it for business cards and some content that you want to display a virtual item on top of. There is also Pictorize Studio, which is a web-based drag and drop editor that you can put interactive web, so this one is using actually MindAR on the background, but you can use it to play some videos. You can use it for something that has some animations, slideshows, flashcards, that kind of thing. So, here's a good use case for it where you has a good tracking and can be playing some animation. Okay, let's go back to Rubik's Cube. This one, I don't know if you can hear it, but this is the largest Rubik's Cube in the world. It's about 1.57 meters tall. And that guy almost got toppled by this huge Rubik's Cube. Anyway, it's interesting. All right, another one is Babylon.js, which is a 3D game engine built using TypeScript. It has full WebXR support out of the box, not just gaze. It also includes teleportation, AR experimental features. It's open source. And it is actually started by, it's maintained by Microsoft, and you can use it to create 3D experiences, animations, games. And it's fast, efficient, and it is flexible. So we go to Babylon.js. There's a way they have and kind of like an editor that you can play with these some of these items. So it supports Android phones, HoloLens, MetaQuest. So they have a playground. If you go to playground.babylonjs.com, there's good examples out there. And it gives you a way, step-by-step instructions how you can play with this. Like in this case, I have a scene. There's the camera. I have to locate where the camera is going to be. I have to specify where like in this case, I wanted to create a background or a model that I want to be able to display in XR experience. If I do that, that's what it's going to look like. So you'll have a 3D background and you can walk around that virtual space. This one right here, there are tools now that you can use to be able to, without wearing the glasses, you can move around the virtual space using the browser. Let's see if I can showcase that one. So for example, let's see, I have, to say on A-frame, you can do Control Shift I, or the visual inspector. The visual inspector allows you to do a little bit of editing on some of these items, right? See if it's going to load there. Maybe it's taking a little bit longer than usual. But there's also some tools, developer tools, in order to help you with to notice how this WebXR stuff. So if you are in VR mode, you can use this to be able to control and kind of see if you have to rotate the camera, or you have to rotate the glasses, kind of what it's going to look like in virtual space. So, and then of course what it looks like on Vive, Quest, those kind of things. So this is I guess one of the add-ons that you can use. It's called WebXR add-ons. That is part of Chrome, that you can include in Chrome, or plugin Chrome. So just a little bit of fact, actually, if you go to Nike.com and if you wanted to play with, kind of customize your shoes, kind of like what I'm showing in video, it uses Babylon.js to do all these customization for you. So it's being used in real world. That's what I'm trying to get at. Another one is 3JS, which is an open source library, which is cross-browser JavaScript library. 3JS has been there for a while. It has large community. A lot of the 3D computer graphics, it's specifically for creating and display animated computer graphics in the browser. But they also added WebXR into 3JS, so it has that capability. So here are some links, and Google even have a tutorial on how to get started guide into working with 3JS and adding WebXR. So here's a good example of that and what that tutorial is. I don't have a lot of time to kind of showcase step by step on how you would do that in 3JS, but here's what that looks like, where you can place an item on a, like here on the desk, and you could have the 3D model on top of that. Okay, going back to Rubik's Cube, the world record of the biggest, or the most complex, I guess, is 33 by 33 by 33. Fun fact, actually, that hash pattern validates that it is a playable Rubik's Cube. So this is one of the most complex one, biggest one that is out there. Okay, so I also want to talk about MediaPipe. It's not necessarily part of WebXR, but it also allows you to kind of have an AR or computer vision or media processing on the that is in JavaScript. It has, if you just need a face mesh, face detection, hand detection, or post detection. There's npm package that you can actually integrate it to your application. There's a lot of demos that you can that's out there, and I think it's very interesting because it's it's kind of like this. If you need something that you can have face detection or what we call the face mesh, that is an example of the face mesh, and you can do something on top of that. Another one is Play Canvas. Play Canvas is open source HTML5 game engine that is built on WebGL, and GLTF. it allows you to not just build games, but in this case now we can use it for visualizations, not just VR and AR. And yeah, it makes it easy because it has an editor online, so not a lot much of coding, but it's more. It allows you to be able to do some, some of these interactions on the web. So let's see if we can get there. This is Play Canvas. So Play Canvas. If you go to playcanvas.com, it allows you to, see if we can log in this one. Yeah. See if it allows me to log in. Yeah, so this is the Rubik's Cube model that I have. I have an editor. I'll go to the editor. I can specify where those buttons are, and these buttons, what it'll do to the 3D model, for for this Rubik's Cube. I can control that a little bit. So there, it allows you to have that capability. Let's see if I can showcase this, and then we'll talk a little bit more about that. Okay. Here's my phone. We're going to Play Canvas. Oh, maybe it's not going to load there. Okay, see this one. This one's running locally on my machine. Let's Play Canvas. Try again. To notice how I can press this left and right button. It rotates the Rubik's Cube. You can also do that in see AR. So notice how it's located in a certain spot. I can press the rotate button left and right, and it does, manipulate the VR or the model in 3D space. So that's what it's doing right now on here. There's tutorials on how you would use it, but at least this is a little bit much visual way of doing that. There's also JavaScript code that's on here. I just want to show you what that JavaScript code looks like. So this one is you're looking for events, and once you have the event, or you're pretty much connecting those events. So when you click this, it will fire an event, another event, and that kind of thing. So that is Play Canvas. Feel free to drop any questions on the chat. I know I've talked a lot. There's a lot of things that I did talk about today, but my point here is not for you to memorize all these tools or learn. I want you to try these tools to see what fits to your project and what you're thinking about. And I just wanted to give you some little bit of comparison here and there. What are things you can do easily on these apps to get you started and get you into these mixed reality space in JavaScript. One good example out there of apps that is available, this Moonrider XYZ. It's a video game where you can start punching these items. And actually, Meta created this demo, and then this is a project. They call it Project Flower Bed, where you can plant your garden, grow your garden, and then you can take a picture of it. And all these are all good example of a WebXR or application that you can try out. Okay. And this one, the robots can solve actually Rubik's Cube in Yeah, 0.637 seconds is able to to be able to, yeah, this robot is able to do that in 0.637 seconds. So yeah, AI is taking over the world and computer vision and doing that. All right, as a summary for what I did present today, what is mixed reality? Mixed reality is a blend of physical and digital world that allows us to have the human with using computing and then each and the environment all working together to have a different experience. What is WebXR? WebXR is mixed reality using web browsers, not just web browsers on your phone, not just web browsers on the desktop or laptops, but also web browsers that are in these uh, VR and AR glasses that are coming up. Vision OS, I'm excited to see that and see how it's going to help our industry. It has web browsers, so it allows us to be able to hopefully make WebXR running there too. What are the open source JavaScript libraries that are available out there that you can start using now? There's the model viewer, there's A-Frame, there's MindAR, there's Babylon.js and 3JS that I did talk about today. The easiest one, if you ask me, to get started is the model viewer, and then of course the A-Frame. And if you want to start digging a little bit more, MindAR allows you to be able to do the poster or the image tracking. And then Babylon.js, if you want to go create games or create specific visualization. And then, of course, 3JS is another one that actually A-Frame is actually running on top of 3JS. MindAR is also running on top of 3JS, is using that. And that is it for me. If you want to get the GitHub link for this presentation, I have the QR code. I will also paste this in the chat for your reference, and also the PowerPoint presentation. If you want to learn more about me, my name is Ron Dagdag. I'm an R&D Manager at 7-Eleven. I'm a Microsoft MVP awardee. The best way to contact me is through LinkedIn. And I appreciate you geeking out with me about mixed reality, also about WebXR and Rubik's Cube. I appreciate you, and I hope you learned something new from my presentation today.